Right, so today we're going to continue looking at 6.1. So we did 6.1 part 1 yesterday. We looked at 3 rules. We just reviewed them. You got the power to a power. You got the product in parentheses raised to a power where the exponent belongs to everything in the parentheses. And then you've got the rule where you multiply with the same base and you add exponents. All right. So today we're going to look at how to divide monomials. Now, let's say I had something like this. 2 times 3 times 4 divided by 2 times 3. Now, I could just multiply out everything that's in the top and write the answer. So I could put like 24, and then I could do 2 times 3 is 6, and then I could just reduce it. But I did a lot of extra work there. Right? What could I have done instead of just multiplying all this out straight across? Yeah.
Simplify.
How could I have simplified?
Divide 2 by 2, 3 by 3.
Right. Anytime you've got the same number that appears in the top and the bottom of a fraction, as long as you're multiplying, you can just cross it out. Right? So the 2 is in the top and the bottom. What else is in the top and the bottom? 3. Look what I end up with. I end up with 4, and I didn't even have to do any work. I didn't have to multiply at all. Everything canceled out, and I got the same answer. Now, is it that hard to do 2 times 3 times 4? Not really. But that's the idea of what we're going to do today. Okay, we're going to be able to cancel things out. Okay, but remember, you can only cancel them out if you have the same thing in the top and the bottom. You've got to have the same thing in the top and the bottom. So if you had something like this, 5 times 7 divided by 3. Is there anything you can cancel there? No. You can't. You can't. If I made this a 3, now you could. Now you could cancel out the 3's and the answer would just be 7. Right? But you've got to have the same thing in the top and the bottom. The way you're going to see it today, it's going to be the same letter. Okay, we're not going to have numbers, we're going to have letters. Right? And once we cancel out, I'll show you an example where we cancel them out. I think then you'll see there's a pattern. There's a shortcut, just like we did yesterday. Right, here's another example where I'm just canceling out the 3's. Let's look at the same idea now with letters. What does x to the 5th mean? Like if I wanted to write that out the long way. Yep?
X 5 times.
Yeah, and what are you doing 5 times? Multiplying. X times x times x times x times x. What about x squared?
Same thing.
Same thing. X times x. So basically you get that. X times x times x times x times x. And then at the bottom, you get x times x. Sorry. Oh, I did. So look at what happens. We have 5 copies of x in the top. We have 2 copies of x in the bottom. Do we have the same thing in the top and the bottom? Definitely. We've got an x here and an x here. Gone. We've got an x here and an x here. Gone. How come I can't cross out the next one?
Because you did 2 and 2.
Yeah, I don't have any more. If I was going to cancel another one from the top, I'd have to cancel another one from the bottom. I can't. So what am I left with? X to the 3rd, right? So all I'm left with is, I changed the problem a little bit, but all we're left with is x to the 3rd. So now, look at this number, look at this number. Do you see any kind of arithmetic you could do with 5 and 2 to get 3? Yeah?
5 minus 2?
Yeah, 5 minus 2. And that's the whole key of what we're going to do today. When we divide monomials, we end up subtracting exponents. So now we've got a 4th rule. We're gonna write it down. But the idea is it's going to involve subtraction. All right? Let's look at this one. Let's see if it... let me just change the numbers up a little bit. Let's do this and let's do that. Okay. Y to the 8th, what does that mean?
Y times
Yeah.
itself 8
It
times.
means y times itself 8 times.
You guys, when you do this, you don't have to list it every time. I'm just showing you the idea of what happens.
And then y cubed.
Y times itself 3 times.
Y times y times y. What can I cancel from the top and the bottom? It's got to be 3 of the y's. 1, 1, 2, 2, 3, 3. So what am I left with?
5.
Y times 2.
Y to the what? 5th. 1, 2, 3, 4, 5. You're like, well, why is it y to the 5th? Just remember, these all have exponents of 1. And when you multiply, 1 plus 1 plus 1 plus 1 plus 1. That's why you get y to the 5th. So it's not really a new rule. It's just based on rules we did yesterday. Okay. And 8 minus 3, sure enough, gives you 5. So that rule works there. So let's do, let's look at what happens with this one. Okay. Any questions on what happened with that one? Okay. When you look at that, where did you have more y's to start? You had more on the top. Okay. When we did this one, where did you have more y's to start?
Top.
The top. Okay. Let's look at this one. X cubed means x times x times x. X to the 7th. 1, 2, 3, 4, 5, 6, 7. Okay, I want you to see what happens this time. Where do I have more x's to start?
On the bottom.
The bottom. Okay, a little different. What can I cancel out here? They still have stuff in common.
The 3 x's.
3 of the x's. 1, 2, 3. 1, 2, 3. How many x's do I have left? 4. But where are they?
At the bottom.
They're in the bottom, right? Before, I had like 5 y's left. They were in the top. I had 3 x's left. They were in the top. I have 4 x's left. They're in the bottom.
Just make it negative.
You can put a negative exponent, but we're going to deal with that more tomorrow. For today, you got to leave something in the top because you got to have a fraction here. So there's everything canceled out. What do we usually put for a number when everything cancels out?
0.
Not 0,
1.
1. So when everything's gone from the top, you got to leave something there. So you put a 1, and what's in the bottom? X to the 4th. That's the only difference when you end up with more x's in the bottom. All right. So notice, but look at it. What's 7 minus 3? It's not 3 minus 7. 7 minus 3. Still 4. Notice how I subtracted it. I always took the bigger number minus the smaller number, and you're always going to get that number. 7 minus 3, 4. 8 minus 3, 5. Okay, as long as we always do bigger minus smaller, you'll get the correct number that goes right there. We just have to figure out, should it go in the top or should it go in the bottom, right? When you had more x's in the bottom to start, your answer ended up in the bottom. When you had more x's to start in the top, your answer ended up in the top. That's the pattern. Wherever you have more x's or y's or whatever, that's where the answer goes. So if you have more in the top, the answer's in the top. More in the bottom, the answer's in the bottom. How do you tell which one has more? Just look at the number. Here, this one has 7, this one has 3. There's more in the bottom. What if I gave you one like this? Which one has more? Bottom. So where is the answer going to be? It's going to be in the bottom. What's it going to be? Well, 15 minus 12 gives me an exponent of 3. It's going to be an x cubed, but it's going to be in the bottom. Okay?
Same idea as yesterday. If the bases are the same, keep the base. Keep the base and subtract the numbers.
Okay, kind of a special case. Where are there more m's? Top or bottom?
4. 3.
They're equal. All right, let's write it out and see what happens. M times m times m. What's the bottom?
M times M.
M times m times m. What can I cancel out from the top and the bottom?
The 3x.
So an m, another m, another m, another m, another m. I've canceled everything. Now, we can't just say, oh, well, here's the answer. It's blank.
It's 1 over 1.
What would you put for the answer? All the m's are gone.
1 over 1.
1 over, yeah. When everything cancels out, it's just 1. All right? So that's kind of a special case.
And when you're dividing something by itself, whatever it is, doesn't matter if you have square roots, whatever, it's always going to be 1.
So we can, I think we might write that one down, but when these are the same, like Mr. Roy just said, when you divide two things that are the same, you always get 1. Think of another problem in your head. Think of like 5 divided by 5. What's that? 1. 12 divided by 12.
1.
1. X cubed divided by x cubed. 1. Okay? Whenever you divide two things that are the same, you get 1. So let's kind of write down this as a rule on your notes. So, to divide two expressions with the same base, you already got that part. You gotta do the underline part. You want to subtract your exponents. But remember how I subtracted them. Did I ever get a negative number?
No.
No, I tried to avoid that. We're going to talk about negatives tomorrow. And the way you avoid that is you always do larger minus smaller. If the larger's in the top, fine. If the larger's in the bottom, fine. You always do larger minus smaller. And remember where we put our answer. We put our answer wherever the larger number was. So you want to remember that, and you got to remember that if you don't have anything there at all in like the top, you got to put something. You always put a 1. Just like when we do slope. If we want to write it as a fraction, you don't have a denominator. You got to put something. You can always put a 1. It's kind of the same idea. So that's the shortcut we're going to use. We're not going to write it out anymore. Especially if you had like x to the 20th power. You don't want to sit there and write x 20 times, right? It's going to take too long. So we're going to use that shortcut to subtract exponents. Not a hard rule, but it's another rule you got to remember. Now, all the rules are pretty basic this week. Very simple. You just got to know when to apply them. Right? When to use which rule. And eventually we're going to get into problems that they have like every rule in the problem. But I think once we do that, we have an order for you. Like do this, do this. You know, we tell you which ones to do first. All right. Anyone still copying? We're good. All right. Okay. So let's look at this one.
So if you have space, for example, 1A, you just have to write it out. That's all.
All right. So in order to divide these, just like if you were going to multiply them, you have to make sure that they have the same what? Base. Do they have the same base?
Yes.
Okay, then we can keep going. Same base, x, x. Are we multiplying or dividing here?
Dividing.
Yeah, you get the fraction bar, so you know you're dividing. So what do you do with the exponents when you divide? Subtract what order? Always.
Top, bottom, or larger, small.
Yeah, it's not where they are, it's what they are. It's larger minus smaller, because we don't want to get negatives. So, larger minus smaller. Now, what's going to happen to the base? Stays the same. Base always stays the same. What's going to be my exponent?
X cubed.
X cubed. Now, why didn't we put that in the bottom of a fraction?
Because the larger number was on top.
Right, the larger number was on top. So if you wanted to think of it as a fraction, you can. It's in the top, right? When it's a 1 in the bottom, I usually don't write it. You don't need to, right? But the larger number was in the top, so the answer is in the top, which we usually just do like
We've
that.
talked about that any number can be put over 1, or any expression can be put over 1. We just don't do it every time.
Okay. Do we have y to the 9th divided by y to the 9th? Are they the same base?
Yes.
What's the base?
Why?
Y. Thought it was 9.
Line
No, it's not. Why?
What's the 9?
That's why.
Oh yeah. So the 9 is the exponent. So y to the 9th divided by y to the 9th. We're dividing two things that are the same. This is kind of a special case. Yeah? You get 1.
Yeah.
Nice one, Chef.
Could you put 1 over 1? It's the same thing. Yeah. Just 1.
What about 2 over 2?
Put 1. So if you put 2 over 2, it's not reduced.
That's true.
Kind of like leaving an answer like this. That's not reduced. You can make it smaller. Make it simpler. All right, this one.
Guys, you don't have space for this one. That's okay. You can add it in there if you want. All right.
What's do we have the same base?
Yes.
Yep. So this is a good one because it's different than the other two. It's the only one we've done, for example, one that does something a little different. Any thoughts on this one before I even start applying my rules?
Yes.
Something maybe we've done this before? Yeah?
Well, it's basically just Z6 because you're adding the Z's together.
I agree we can combine them somehow, but not quite like that. Right now, I gotta put my X-ray glasses on to see something. I don't want to use my X-ray glasses. I want to make things visible. Yep. Where, right? On the exponent. Right? If you don't have an exponent, put it as a 1. Okay. We have the same base. We know we can combine. Where is my answer going to end up?
On the bottom.
Why?
Because the exponent's on the bottom.
Right, because if we were to cancel all the z's out, there's 1 in the top, there's 5 in the bottom. You're going to be left with some in the bottom. So we know the z is in the bottom. The question is how many? What's the exponent? 4. 5 minus 1. But you can't, if you leave it like that, you're going to lose points. Put a 1 in the top. You can't have a fraction with an empty numerator. You got to put something there. All right? So 1 over z to the 4th. This one's actually a little bit easier because it's numeric. When it's numeric, they're going to want you to simplify it. I mean, if it was something crazy like 4 to the 600th power, we're not going to have you do that out. But this is going to be pretty small. No, that's too big. That's way too big.
There's a 1D.
1D.
Yeah, I don't think you have, I don't know if you have room for it, but,
Yeah, write this one in.
but this is a good one because
Yeah, definitely write this one.
numeric is important.
Add this in.
Okay, do I have the same base? Yes. What's the exponent on the bottom? What's the exponent on the top? Let's make it visible. Okay. When I'm combining, because we just said they have the same base, what's going to happen to the base? Stays the same. Where is the base going to be?
On the bottom.
Why?
Because we have to leave it on the bottom.
Bigger exponents on the bottom. Now I need the exponent on the 4.
So 4.
Oh, just make it the same as the base all the time? You said it was 4. Oh, from 5 minus 1, yeah. So 5 minus 1, just a coincidence, it comes out to 4.
And then 1 would be on the top.
And then a 1 is on the top. All right? So now if we do that out, I'll just tell you what it is. It's 256. If you use your calculator and type it in, maybe I should show you. 4 to the 4th power. 256.
Again, remember, it's not negative, so you don't have to worry about putting it in parentheses. When it's negative, make sure you put it in parentheses.
Yep. Yep. If these were all negatives here, I would have had negatives throughout the whole problem, but I'm not going to put that in. Any questions on that one? So pretty straightforward. Every problem there just had one base, right? I think we're going to get into some now that have
I'll do this part.
a couple big. No.
So as Mr. Hager was saying earlier, some of the stuff we learned yesterday, we're gonna have to apply to some of this stuff, like the power to a power, the adding the exponents. You may have a problem that, and again, like it says here, very important to understand, you may not have to do every single step. Right? You may have to only have to do 1 or 2. We're not gonna get, we're not gonna get super involved with that. We may give you like 1 that has every step, but we're not gonna go too in depth with this stuff. All right. So first thing you want to look for is, does it have power to a power? So that means we want to take what's on the outside and make sure you know here that we're multiplying there. So that's a rule that we talked about yesterday, that power to a power. Take the number, the exponent on the outside, multiply it by the exponents on the inside. Always keeping the base. Right? Always keeping the base. You don't have to write this, but if it was like x2, y3, 2 on the outside, it'll become x to the 6th, y to the 6th. Or again, when the exponent's on the outside of the parentheses, we want to multiply it by the exponents that are on the inside of the parentheses. We're not adding here. We're multiplying because we have the number on the outside of the parentheses. Right? So that's power to a power. You may have that, you may not. So again, we're just kind of going through, kind of like when we did like the step looking at elimination. We had the different cases, like same number, same letter, different sign. Okay, it had that, we could use that. If it didn't, we went on to the next step. Kind of the same idea. It's kind of like a checklist to follow. The order you want to do when you're doing these type of problems. Right, so first thing, like we said, is power to a power. Next, we want to reduce our whole or our big numbers that have exponents attached. So on your reminders, where it says simplify big numbers, if I add 3 to the second, I want to make sure I made that 9, because it means 3 times 3. If I had 2 to the second, 2 times 4, it would 2 times 2 would simplify to 4. So I want to make sure I made all my whole. If I have any whole numbers that have exponents attached, I want to simplify them. Either do it in your head, just know that, remember, it's the big number multiplied together as many times as the little number says. 3 to the second, 3 times 3. 2 to the fourth, 2 times 2 times 2 times 2. You want to simplify that. And again, if you're not sure, use a little caret, a little button like this on your calculator. Make sure if it's negative, put it in parentheses. All right? So you want to make sure you reduce. And again, like I said, you might not have every single step to do. You might only have 1 or 2 things. All right? We want to add exponents with the same base on the same level. You don't have to write this, but if I had like x2, x3 over 5, I have the same base, x, on the same level. So it will become x to the 5th over 5. So I want to make sure I add my exponents with the same base on the same level. Again, I'm going to say it again. You may not have every step. You may only have 1 or 2 things you have to do off this list. And guys, tomorrow, like Mr. Hager said, we're going to talk about negative exponents. So tomorrow, we're only going to add 1 step to this list. We're only going to add 1 step. This is a step that we talked about today. All right? We're going to subtract exponents with the same base on different levels. So if we had x2, y5 over y to the 3rd. All right? I have the same base on different levels. I had a y on the top and a y on the bottom. All right? So I'm dividing those, but I'm actually going to subtract the exponents and put my answer where the bigger exponent was to start. So this step right here, step 4, is the rule that we talked about today. So when we're multiplying exponents, we're really adding them. When we're multiplying exponents, we're subtracting them. And then when we have the exponent on the outside of the parentheses, we're going to multiply. Then last thing is, like Mr. Hager, like if we had, he showed you before, if we had like 6 over 4, then we have to reduce that. Alright? So we want to reduce our big numbers. So here, for an example, if I had like 4 over 2, it would reduce to 2. Alright? Or if I had, because in this case I had the bigger number on the top, smaller number on the bottom. If I had this, smaller number on top, bigger number on bottom, what I did here was I divided both the top and the bottom by 3. 3 can go into both, so it reduces to 1 over 3. Alright? So that'd be the last thing you want to do. And like I said, tomorrow, we're only going to add 1 step to this. So tomorrow, what we'll do is, guys, I'll probably have all the other steps from today filled out You only have to write it down one step. I'm not gonna rewrite the whole thing because you already have it. And what I'll do, guys, I think this might be helpful. So what I'll do is I will put this on the, we will put this on the reference sheet so you have it. All right? Everybody has this?
Yep.
Good?
Yeah.
Good. All right. So, make sure you divide monomials with more than one variable. All the variables are aligned in the same columns. So here, we have our whole numbers, our 6 and our 3. We want to make sure they're over each other. I have my x's, I want to make sure they're over each other. I have my y's. And again, you may have a's, you may have b's, you may have different letters. It might not always be x and y. All right? And like we said, the bigger number, right, or we call the 6 and the 3, those are constants. They can't change. We could plug something in, we could plug a number in for x, we could plug a number in for y if we wanted to. But the 6 and the 3 won't change. 6 is 6, 3 is 3. If I was going to reduce those whole numbers, the 6 and the 3, what would it reduce to? I don't really care about the x's and the y's right now, but if I had to reduce the 6 and the 3, what would it reduce to?
2.
2, right? Because 3 goes into 6 2 times. Or if we wanted to say we wanted to divide by 3, I'll get 2 over 1. Or just like Donovan said, it would just be 2.
Yeah.
Right? So that's one, like the reducing part, that's something that we're really not talking about this week. We're really focusing on the rules for the exponents. But again, it's something that you have to know and have to be able to do. Alright. So let me do this. I'm just going to do it, guys, so we can see the steps and also go through the problem and see what we have. Alright. So for this one, first thing says what I'm looking for is power to a power. So I just want to.
That's a 5 or 3.
This is a v. V to the fifth times v to the third over v to the second. V to the fifth times v to the third over v to the second. Vive la France. All right. So.
Okay, I can see it.
For this, do we have, Joe, for this, do we have power to a power? We do. No, because why? There's no parentheses, right? Cool. Next thing says, reduce whole big numbers with exponents. So like, do I have any whole numbers?
Yeah.
I do?
5 and 3.
Those are exponents.
Oh, I thought you were talking about fractions.
No. So I don't have any whole big numbers with exponents. Next, add exponents with the same base on the same level. Nicole? I do. Where? Top or bottom? Okay, what's the base? V. And what's my exponent going to be? 8.
Hey, to be 8.
I had a base that was the same, V, on the top, and I just added the numbers. All right. Every time I do a step, I may not do something to the top. I may not do something on both levels. So I want to make sure I just bring my whatever I didn't use, just bring it over. All right. So in this case, we had exponents with the same base on the same level. All right. Step 4. Subtract exponents with the same base on different levels. Put answer where the bigger exponent was. Bethany, what do you think? Do we have the same base on different levels? What's the base? V. All right, so it says put the answer where the bigger exponent was. So where's my V going to go? On the top, right? Because there's an 8 here. What's the exponent going to be, Bethany? Huh? What am I doing with these two numbers? What operation? Subtraction. So what do I get? 6. V to the 6. I didn't do anything on the bottom, so I can put a 1. But the actual answer, you don't have to. If you didn't do this step, that's fine. I'm just showing you that if you want to put it over 1 and give yourself one more step to make it v to the 6th, you can do that. All right? Do I have any big numbers to reduce? No. I just have a variable of variable of v, and then my exponent is 6. All right? I'm gonna go. So that's that. This one. All right. First thing.
Is that like negative 13x?
Yeah, so it says negative 13 x to the 8th y over 26 x to the 4th y to the 5th. So the little note we had before is we want to make sure the numbers are lined up, the same variables are lined up, and the same variables. Numbers over numbers, x over x, y over y. I'm all lined up. I'm good. Everything's in order. All right? Do I have, Miguel, do I have power to a power here? Do I have step 1 here, power to a power?
No.
Why? I don't have any parentheses, right? So there's no power to a power. All right. Reduce whole numbers, all right, with exponents. I have some whole numbers, but do they have, is the exponent bigger than 1? No. So I'm not doing step 2. Add exponents with the same base on the same level. Do I have that? Nicole, I don't? No. I got an x and a y on the top, and I got an x and a y on the bottom. I can't do anything with that. All right. Use of subtract exponents with the same base on different levels.
So you can do 8 minus 4 from the x's.
Yeah. So the negative 13 and 26, I can't do anything with those, right? Right now, I'm not at that point. So what I'm going to do is, I'm just going to bring them over and write them down. And you just said I got x8 and x to the 4th. What am I going to get? Where's it going to go, top or bottom?
Bottom. I mean top.
Top.
Yes.
So it's going to be x to the what, Yusuf?
4th.
Good. Again, I'm putting it there because why? Yeah, that's where the bigger number was, right? So if you want, guys, you already did this. You already did that part. You can cross it out. Nathan, do I have any other bases that are the same on different levels?
Yeah, y.
Y, okay. So what do I get when I simplify that?
Y can,
Y to the 4th, okay, so there's a 1 with this y. Where's it going to go, top or bottom?
bottom.
Bottom, right? Because 5 is bigger than 1. Got that. All right. Reduce the big numbers. Right? So my two big numbers are negative 13 and 26. Guys, most of the time with this, the smaller number can go into the bigger number. Can 13 go into 26? How many times? Twice. So where's the 2 going to go, on the top or on the bottom? On the bottom, right? Because negative 13 goes into 26.
Okay.
It'll be 2 times y on the 4th, x to the 4th. But now, I'm doing a negative divided by a positive. So should my answer be positive or negative?
Negative.
Okay. So I can say it doesn't matter if I put it on the top or the bottom. Does it matter? No. I can put it there. I can put it on the bottom. As long as you have the negative sign somewhere, you're good. But just don't put the negative on the top and the bottom. So that means you're gonna make it positive. All right. So there's your final answer: negative x to the 4th over 2y to the 4th. So in this one we had, I think in both of them so far we've had 2 steps. The first one we had step 3 and step 4. And then in 2B, we had step 4 and step 5. So most of the time, you're only gonna get like a couple of steps. Maybe sometimes we might get 3 or 4 steps, but usually there's gonna be more, there's be a couple steps, that's it. All right? All right. So now, for this one, do I have, I do, right, Nicole, I have power to a power because I got parentheses and I got a 3 on the outside. Now that third power, right, where am I going to be like applying that? On the top only, on the bottom only, or on both levels? Both levels, right, because it's around the whole thing. So what should that negative x, what should I put with it?
Would it be negative x to the third power or no?
It'll end up becoming that, right? But before I do that, if I don't have any exponents, I'm going to put a 1, right?
Yeah, because
I'm going to put a 1 on the top, I'm going to put a 1 on the bottom. And like we just talked about, I'm going to apply that 3 to the top and the bottom.
so that should be negative x3 for squared. No, that's cubed. I don't know why I think that's
So here's my fraction. On the top, what am I going to have? Guys, enough. It's getting annoying. It was funny for a while, but then you kind of overkilled it, okay?
May I redeem myself?
Yeah.
Negative x cubed.
Negative x cubed. On the bottom,
Negative, no, 4 cubed.
4 cubed.
There's no negative.
All right? On the top, I got negative x to the third, right?
Yes.
It can stay like that. All right? Like we talked about, you know, say no mistake?
We should have parentheses.
Yes.
Because you're cubing the x and you're cubing the negative with it. It's like you're cubing a negative 1.
So with this, like we talked about a little bit yesterday, when I have a negative base and an odd exponent, my answer is going to be negative. When I have a negative base and an even exponent, my answer is going to be positive. Because this really means negative x times negative x times negative x. So this negative times a negative will end up being positive x times negative x. Positive times a negative is a negative. So like I said, if you have a negative base, odd exponent, negative answer. Negative base, even exponent, positive answer. So I'll get negative x, 3 over 4 to the third. All right, so we have power to a power. Reduce whole big numbers with exponents. Do we have a whole number that has an exponent attached? Do we, Ryan? We have a whole number with an exponent attached. What is it? 4 to the third, right? I'm going to take my calculator.
And do 4 times 4 times.
I can do it like that. What's a quicker way?
Do the parent.
third.
Yeah. And again, do I have to put parentheses around this one?
No,
No, how come?
because it's just an exponent.
Okay. Remember, we want to put parentheses when we have a negative base. If you have a positive base, it doesn't matter. So we're going to get 4 to the third. So 4, 3, 64. 64 is going to go on the bottom. Negative x 3. All right. We did that. Add exponents with the same base on the same level. Do we have it?
No.
No. Yeah, because we have a negative, we have an x, we have a 64. Subtract exponents with same base on different levels. Put answer where the bigger exponent was. Do we have it? No. Reduce big numbers. I mean, there could be a negative 1 on the top. We didn't write it. That's not.
That's not going to help.
Yeah, it doesn't matter. So our final answer is negative x to the third over 64. So another one that had 2 steps. Right, so as you guys can see, most of them are going to have 2 steps as we get into 3. All right? Alright, this one, similar. Jake, do we have power to a power here? Do we have parentheses? We do, perfect. So Jake just said we have power to a power. Alright. Just like the last one, am I applying that second power on the top, on the bottom, or on both? What do you think, Chris? Top, bottom, or both? Top level, bottom, numerator, denominator, or both the numerator and denominator? Is that second power going to go to top, bottom, or both? What do you think? Matt, what do you think? That second power, am I going to apply it? Is it going to go only into the numerator, only into the denominator, or both the numerator and the denominator?
I'm thinking both.
I'm thinking both, I'm thinking I agree with you. Alright? How many things on that top level, or the numerator, how many things am I applying that second power to? What do you think, Nicole? 2. Okay. Even though there's not an exponent written with that 6, what's there? 1. Any variable or any letter or any number is always written to the first power. It's always written to the first power. You're just going to make sure. I'm not saying, like I said to you guys yesterday, I'm not saying that you have to write that. I'm not saying you have to write the 1 every time. If you know that it's to the first power, you don't have to write it. But if you have a hard time remembering, or it's going to make you make a little mistake, I would write it in. Alright? So I'm going to, like Nicole said, I'm going to apply it to both things. To that and to that. To the first power with the 6, to the third power with the x. Do the bases stay the same? Do the bases change at all when I do power to a power? No. So, even before I do my power to a power, what are the 2 bases that are going to be on the top? 6 and x. What's the base that's going to be on the bottom? 7. Perfect. Brady, what exponent is going to be with the 6 now? If we're doing power to a power. What exponent is going to be with the 6 now? No, what exponent? So I have a 1 here, I have the 2 on the outside that I'm going to apply to that. So what's the exponent going to be with the 6? What's the small number going to be?
I don't know.
What, when we do power to a power, what operation do we use? What operation do we use when we do power to a power? If it was something like this, if it was like x to the third times x to the second, we add, right? And we get x to the 5th. But we have a number on the outside of the exponent on the outside of the parentheses, and I have to bring in what operation, Chris?
You multiply.
Multiplication. So Brady, we're multiplying, right? So what exponent is going to be with the 6 now, if I'm multiplying?
Is it 3 and 2?
So I have 2 on the outside, and I have 1 here.
Oh, 2.
2.
So
So
what about the 3?
we'll do that in a second. I'm just doing it separately. So 2 times 1, 2. Again, I'm applying that. I'm bringing that 2 into both exponents that are there. The exponent of 1, that's with the 6, and the exponent of 1, that's with the 6. The exponent of 3, that's with the x. All right. So I just did my 2 times 1, which is 2.
So then it'd be 3x. Wait, no, then it'd be x to the 6.
Good. Yeah, it'd be x to the 6, because 3 times 2, 6. Remember, like we talked about, just like on the top, this 7 is to what power? To the first. Garrett, what exponent is my 7 going to have now when I apply the 2?
2.
Yeah, so we're multiplying, right? Like Chris told us. 7 to the second. All right? Next step, do I have whole numbers that have exponents attached?
Yes.
Dylan, what's one of those whole numbers that has an exponent attached?
6.
6. 6 to the,
Second.
what's that mean?
Squared.
Squared.
Yeah.
6 times, does it mean 6 times 2 or 6 times 6?
6.
That's right.
It's 36.
It could be, usually when it's to the second power, you can do it, 36, but again, you can use a calculator, 6, caret button, 2, it'll give you your answer. Remember, if it's negative, make sure you put it in parentheses. 36 on the top. X to the 6, I can't do anything with it. On the bottom, 49, like Nicole just said, 7 times 7, not 7 times 2, 49. All right. Do I have same base, same level? No, I have a 36. I don't have any other 36s. I got an X, no other X's. I got a 49, no other 49s. Same base, different levels. No. 36, 49, X, no X on the
So
bottom.
then we reduce the big numbers?
I can reduce the big numbers. Now, like I told you guys, always look and see if the big number can go into the small number. Can the big number go into the small number?
No.
No.
You can reduce it.
By what number?
9.
9?
Oh, wait.
No.
3. Oh, do you know how to work?
Well, I know that, I don't think there's any numbers that can go into 36
What the
or
hell?
49 easily.
Okay, is there any numbers that go into 36 and 49? That's what I thought.
I'm pretty sure.
Alright, so this right here is your final answer. There's not one number that can go into both 36 and 49. Alright? So right here, this is the final answer.
So if you look at it, like think of the top, right? The top is 6 times 6. What are numbers that go into 6?
2,
2s, 2s and 3s. So 2s and 3s go into the top number and 6. Then the bottom number is made up of a prime number times a prime number. 7 and 7. What numbers go into 7?
No set.
Nothing. That's why it's prime. 7. So that's why you can't do anything with it.
So that one had, what, 2? Another one that had 2 steps. So most of the stuff we learned, yesterday, the power to a power, the multiplying the exponents, we add them together. Again, you're going to be able to apply that stuff to some of these. All right? There are some guys, leave your notes up. There are a couple of practice problems. We have like 8-9 minutes left. So homework tonight's like 10 problems. There were six that deal with what we talked about today, 4 from yesterday. Remember review day on Thursday? We'll probably do it kind of like we did before, like the academic week we had before vacation. We'll give you like a worksheet to do first with some like practice questions. That'll be like the review that we do, and we'll do the actual whole class review for some bonus points. Remember, second test of fourth quarter is on Friday. Even though it was third quarter, our last academic week, we counted that test for fourth quarter. All right? Reference sheet, we're going to try to get that posted by the end of the day today. Like I said, all the steps, there'll be space to write in all the steps. If you want to do that, remember, it's not optional, but again, with all the steps this week, it might be helpful for you guys to write that stuff down.
Mr. Wright, is it optional or not optional?
Oh, it's optional.
Okay.
Whoops.
It's not
It's not optional. It's optional. And then, remember, Mr. Hager and I will both be after school on Thursday. We're coming down to it, like we talked about yesterday. We have this week, next academic week, which is the full week, and then the 2 academic weeks after that. 1 week we have MCAS math for the sophomores, so we're only in class for half. Those 2 days, you're only in academics for half the day. That's going to be a short week. And then next week after that is finals. So you guys that are kind of skating right on the edge of passing and failing, you want to make sure you're doing everything that you can do to make sure you pass.
It's just crazy that like just yesterday was starting.
Goes by fast. Yep, good. So you guys have space on your notes.